Okay, we are recording. All right. Solving equations and inequalities. The thing that I really truly believe is I think example 1 and example 2 you guys will remember pretty good from your Algebra 1 class. Even though it was 2 years ago, I don't think you're going to have too much trouble with those. The hardest problem is by far example 3, and you can kind of see it down here. It's just loaded with fractions. So when I quiz you on this standard, when the test comes up, you will have problems like this, but this is really going to be the one that messes you up. Okay? But I'm going to go through these, still ask questions if you have them, and then we'll really spend the majority of our time on number 3. All right. In an equation, if there is distributive property, you have to do distributive property first. So when this -7 is right outside these parentheses, I have to start with this. So I got to do -7 times both. So -7 times -6 is positive 42. -7 times this is negative 56n. And everything else I'm just going to bring down. Okay, from here, there's different things you could do. Order doesn't really matter at this point. You could do it in different steps. I always solve my equations in the same order. So the next thing I look for is, are there like terms on either side? So this side there's not like terms. I have a constant and a variable. But over here I have two constants. So I'm going to combine those. So 42 and positive 3 make 45. And everything else comes down. Okay, after I combine like terms on both sides, now I'm going to combine like terms, but I've got to go across the equal sign. So when I go across the equal sign, I have to do the inverse or the opposite. So if I have negative 56n here, I'm going to do plus 56n on both sides. Okay, so now I've got negative 16. This becomes positive 61n equals 45, and that's gone. Okay, next, I'm going to combine my constants, but I have to go across the equal sign. So again, I have to do the inverse or the opposite. So this is going to be plus 16. This is going to be plus 16. And now I have 61n equals 45 plus 16 should be 61. All right, 61n means 61 times n. So to get rid of 61, we do the inverse. The inverse of times is divide. So I'm going to divide both sides by 61. And my final answer is n equals 1. Okay, it does say check on Desmos. So let's do that now. In Desmos, you can plug the whole equation in and it will tell you an answer. But whenever you take a standardized test, when Desmos is built into the test, it will not solve equations for you. So I'm just going to show you the workaround that Mr. Witcher showed everybody. So if you had him, you're probably fine. I forgot what the problem was. So I'm going to just plug in the left side first, negative 16 plus 5n. So negative 16 plus 5, and Desmos doesn't like n's because it's on an xy axis, so I just switched it to x. Okay, on a different line, I'm going to plug in the other side. And actually, someone that wrote it down, I want you to read it out to me. Negative 7, parentheses, and then what's it after that?
Negative 6 plus 8.
Thank you. Plus 8x? That's it? Or no, plus 3?
Plus 3.
Okay. All right, so I've got my two lines graphed up here. All I've got to do is find where they intersect and click on it. And I'm looking for what x equals because we switched n to x. So in my coordinate point, I'm messing with x. I don't care about that y value. So this is saying that x equals 1, which is the same thing that we got, so we're good. Okay, so I just want to make sure I showed you that workaround. Anytime you have an equation, even if it's on a standardized test, you put it on the two lines, you click where they intersect, and that x is your answer. Questions on number 1? Okay, real quick, I want you to rate yourself. If I gave you a quiz on a problem just like this right now, I want you to rate yourself between 1 and 5 on how you would do on that quiz. 5 means guaranteed to get it right. 1 means guaranteed to get it wrong. 2, 3, and 4 in between. Hands up. If you are rating yourself a 1, do it with the appropriate finger. Okay, hands down. Good. Okay, moving on. Moving on. This is an inequality. How I know it's an inequality is because it has an inequality sign. All the alligator mouths are actually called inequality signs. All right, so, and I also notice up here in the directions, after I solve this, I also have to graph it on a number line, no problem. Inequalities are exactly like equations except for one rule. Everyone forgets this rule, but the one rule is if you multiply or divide by a negative number at any point, you have to flip the inequality sign. That's the one thing everybody forgets. I actually don't think we run into that in this problem, but we'll go ahead and do it anyway. All right, so the first thing I'm going to do, I see my distributive property. I'm treating it just like an equation, so the first thing I have to do is my distributive property. So I get 18b minus 3, and then I'm copying the rest of this down. The next thing I look for is, can I combine like terms on either side? Nope, and nope. So now I've got to go across. So if I'm going to get this negative 3b across over here, I've got to do the inverse, which is plus 3b. So now I've got 21b minus 3 is greater than 18. I'm going to get my constants together. So in order to go across, I'm going to do the inverse. So now I've got 21b is greater than 21. Last step, I'm going to divide both sides by 21. And I get an answer of b is greater than 1. And I'm going to box my answer. At no point did I have to worry about flipping. The only time I multiplied or divided is I just divided in this last step here. And I divided by positive 21, so I did not have to flip that arrow. Okay, graphing on a number line. Super simple. Okay, let's draw a number line. When you were little, you always put 0 in the middle of your number line. Now that you are grown, you don't have to do that anymore. Whatever number we're messing with, I put in the middle. So we got 1 for an answer, so I'm just going to put 1 in the middle. And then just fill in numbers on both sides. So I'm going to put a 2 and a 3, and I'm going to put a 0 and a negative 1. That's super useful when you have a number like, if you have something like b is greater than 1,742, you don't want to put 0 in the middle when it's a big number, just put your 1,472 in the middle. Okay, I really want to make sure we're clear on this next part because the next thing we're going to do pops up all year long in all sorts of different units. Okay, these inequalities and what we're about to draw right here come up all year long. All right, I am just drawing a picture of where the answers to this problem are. So let's discuss answers. Can B be 1? No. Okay, 1 is not greater than 1. That would not make a true statement. So 1 is not one of the answers to B. Can B be 1.01? Yes. Okay, so what we're going to try to show in this picture is that B is every single number bigger than 1, but not including 1. And why it gets tricky is because of all those little tiny decimals. So if I put an open circle above 1, that is our symbol to show that our answer starts right here, but it is not 1. Okay? So now I'm just going to draw an arrow in whichever direction all infinity of the other answers are. If your teachers told you that this arrow always points in the same direction as our arrow, that is not always true. Okay, so forget that. Instead, just use common sense. Can B be 2? Yep. Can B be 3? Yep. So 2 and 3 this way is where all infinity of our answers are. Any questions on that? Still okay? All right, let's get to the hard one. Okay. Let me just get a raise of hands real quick. How many people do not like fractions? Hands up. It is usually the majority of the class. Hands down. How many people don't really mind fractions? You're fine with them. Fair enough. People that don't mind fractions, if you want to work the whole problem out with fractions, you are always allowed to do that. Whenever I'm doing a fraction problem on the board, I teach to the majority of the people, which is the people that don't like fractions. So I'm going to get rid of the fractions for all my fraction haters. Okay? The number one thing people mess up when they are trying to get rid of their fractions is they try to do it right away. But what you have to be careful of, if there's distributive property, we cannot get rid of the fractions until we take care of the distributive property. Right? So when I see this negative 3 in front of this binomial right here, it needs to have an alarm in your head that says, I cannot get rid of fractions until I distribute first. Okay, so I'm going to do that. I am going to do negative 3 times this and negative 3 times this. All right, so off to the side, I'm going to do negative 3 times 1/2 just on my scratch work off to the side. All right, and this is just quick review on how to multiply fractions. I need to turn this whole number into a fraction. And then the rule with multiplying two fractions is I multiply straight across. So I get negative 3 on top, 2 on the bottom. So negative 3 times 1/2 x is negative 3/2 x. For my second multiplication, I'm not going to write it out on scratch paper again. I'm going to show you kind of how I actually do this. I just visualize this negative 3 being negative 3 over 1. So I kind of just picture the 1 on the bottom there. And I picture when I multiply that times this 2/5, I'm still just going straight across. So negative 3 times 2 is going to be negative 6. And on the bottom, 1 times 5 is going to be 5. Okay, and I'm going to bring everything else down. Okay, I've done my distributive property. Now, if I hate fractions, this is the time to get rid of them. For all my fraction haters, you need to become best friends with LCD, which is the least common denominator. Okay, and I actually intentionally made this equation to be one that's tough to find the least common denominator. Usually it's easier than this, but I tried to pick one that was pretty tough so we could think about it. How you find the least common denominator is you look at all of the denominators in your problem, so 3, 2, 5, and 4. I don't care about anything else right now while I'm finding my LCD. And I need to figure out what is a number that all of those denominators can go into evenly. Okay, the first number that popped into my head was 30, because I know 5 goes into 30, 3 goes into 30, 30 is an even number, so 2 goes into it, but 4 will not go into 30. Okay, does anybody know the number offhand? This is a hard one. 60, very nice. The LCD is 60. 5 goes into 60, it's even, so 2 goes into it, 3 obviously goes into 60, and 4 times 15 is 60. Okay, so this is a tough one. All right, here's what you do with your LCD. Once you figure out your LCD, I have to multiply it by every term in the equation. All right, and I'm really trying to emphasize the word term. How many terms are in this blue equation? There are 5 terms in this equation. Okay, each one of these is a term, not just the ones with variables. The constant is also a term. Okay, so there are 5 terms in this equation. So all 5 of these terms need to get multiplied by 60. All right, the rule is you can multiply by whatever you want as long as you do it to everything. All right, here's how I'm going to write it. And this gets kind of messy because it's all crammed together. But I'm going to write times 60. I wrote my 60 on top because it's the same thing as 60 over 1. And I know that I'm going to be multiplying straight across. Okay, and all these other ones, I'm not going to write 60 over 1. I'm just going to multiply by 60 on top each time. And then with the constant, I'm going to multiply by 60 as well. One of the biggest mistakes year after year is people forget to multiply a constant by the LCD as well. But everything needs to get multiplied by the LCD. All right. We are now going to do 60 over 1 times 1/3. 60 over 3 is just going to be 20, and don't forget your x. Okay, next one, negative 3 times 60, negative 180. Negative 180 over 2 is going to be negative 90. Don't forget your x. Offhand, I don't know what 360 divided by 5 is, but here you can also cancel. 5 goes into 5 one time. 5 goes into 60 12 times, so that's canceling. And now it's a little bit more manageable. Negative 6 times 12 is negative 72. Okay, and then I got equals. Here I'm going to end up with 60 over 4, which is 15. Don't forget your x. And then in the back, negative 4 times 60 is negative 240. I have big numbers, but most students prefer big numbers over fractions. Okay, and our LCD was big. Our LCD was 60. If it were a smaller number, then they wouldn't have got this huge. They don't always get this huge. All right, I'm going to work a little faster from this point down because this is now exactly like example 1, where the next thing I'm going to look for is, can I combine like terms on either side? And over here I can. 20x and negative 90x is negative 70x. Bring everything else down. I'm now going to get my variables together, but I'm going across the equal sign, so I have to do the inverse. So I'm going to do negative 15x on both sides. I could have done plus 70x on both sides. That would have been fine. It doesn't matter. Either way is fine. Okay, so now I've got negative 85x minus 72 equals negative 240. I'm going to get my constants together, but I got to go across the equal sign, so I'm doing the inverse. Okay, so I've got negative 85x is equal to, this is negative 168. I'm not that smart. This is just the third time I've done the problem today. Probably shouldn't have said that on the video, actually. Last part, I need to divide both sides by negative 85. So I get x equals, I have a fraction here which is fine. The only thing I need to check and see is if I can reduce the fraction. Because if you can reduce the fraction, you must reduce the fraction. I'm going to show you the easiest way to reduce fractions ever. And it does not, especially with big numbers where it's hard to look at it and see if it's going to reduce. I'm going to use Desmos. So I've got negative 168 over negative 85. I'm going to get rid of these, and I'm going to do negative 168 divided by negative 85. 85. Okay, it gave me a decimal. Okay, looks like an irrational decimal that goes on forever with no pattern. There is a little fraction button over here on the side where if I press this fraction button, it's telling it to give me a fraction answer. All it did was it got rid of the negatives, which makes sense because a negative over a negative just equals a positive, and it gave me 168 over 85 as an answer. What that means is 168 over 85 cannot be reduced. If it could be reduced, it would have reduced it and given you a different fraction right here. So anytime you have to reduce a fraction, you're allowed to plug it into Desmos and let Desmos reduce it for you. Okay? The other thing I